In this video, I will discuss some JEE Main PYQs from the topic motion in a straight line. For some basic ideas, let me consider motion along the x-axis, say like this. So the displacement x and velocity are related as rate of change of displacement is velocity. So this I can rewrite as change the displacement dx equal to v dt. Integrating both the sides, so between the time interval I'll get the displacement made in this time interval as this can be interpreted as area under the velocity time graph between the limits t1 to t2. Suppose the velocity time graph looks like this. So this is time t1 say, and this is time t2. So the displacement made in this time interval t1 to t2 is this area. You can also relate acceleration to the velocity as rate of change of velocity. This can be written as change of velocity with respect to the displacement into dx by dt. This is nothing but v, so it's v into dv by dx. So acceleration is how the velocity is changing with respect to displacement into the velocity. This is also another basic idea. When acceleration is uniform and constant, that is, it is not changing with space and also with time, then there will be a number. In this case, the equation of motion is equal to ut plus half a t square is valid. So the distance traveled in nth second is distance traveled in n seconds minus the distance traveled in n minus 1 seconds. So the motion is along the x-axis like this. Say this is t equal to 0, t equal to 1 second, and here it is at n seconds, at n plus 1 second, it is here at n plus 2 like that. So this nth second is, first second is from 0 to 1. So here say it's n minus 1 second. So nth second is from t equal to n minus 1 to t equal to n, because first second means the distance traveled between the interval t equal to 0 to t equal to 1. So that's why the distance traveled in nth second is distance traveled in n seconds minus the distance traveled in n minus 1 seconds. So if you put t equal to n here, you get u n plus half e n square. This is first term. And the second one is n minus 1. U time is n minus 1 plus half e n minus 1 square. This is second term. So this un and un will get cancelled because of the minus sign, and you get u if you combine these two. And the second one, if you combine half a n square and n square will cancel, minus 2n will become plus 2n because the minus sign here, and plus 1 will become minus 1. So this is the expression for distance traveled in n seconds. U plus half a n minus 1. So you can remember as ut, where t is the time interval 1. So time is just 1. And then half a t square. T square becomes n square minus n minus 1 square. So n square will go, the cross term will be there, and will be the minus sign, so 2n, and the plus 1 will become minus 1. So with these basic ideas, you can solve these JEE Main questions. These questions have appeared between the years 2022 to 2025. I'll discuss some 5 questions. This is the first one. The motion of an airplane is represented by velocity time graph as shown below. The distance covered by airplane in first 30.5 second is dash kilometer. 4 options are given. You can pause and attempt this question. V versus T graph is given. From that we have to find the displacement. So velocity is dx by dt. So from this you'll get x. So between the interval 1 to 2, t1 to t2 is v dt integral between the time interval 1 to 2. This is nothing but area under the curve. Here the time interval is first 30.5 seconds. That means from t equal to 0 to 30.5, somewhere here. So this area should be found out. So the area 0 to 2, I can find out like this. This rectangular area plus this triangular area, the top triangle. So 0 to the area is, this is 2 into 100. So area between the interval 0 to 2 is 2 into 200 plus the triangle area half into base is 2 into height is 200. So 3 times 200, which is 600 SI units. Velocity meter per second, that is second. So this will be meters. And then area under the curve in the interval 2 to 30.5. 2 to 30.5 seconds is this second rectangle. So this side of the rectangle is 28 into the height of the rectangle is from here to here 400. That is 420. 4 times 20 is 80 plus 4 8s are 32 into 100. Multiply by 4. 8 4s are 20. Okay, so it's 1 1. Another way to get this 25 plus 3. So 25 times 4 is 100 plus 3 into 4 is 12. So 112. It's correct. So 112 00 SI units meter. So this is half into base into height. Sorry, I made some mistake here. It's 30.5, right? So this thing is 28.5. So plus 0.5 into 400, that is 200 plus 200 plus 200. First 30.5 seconds. So 30.5 minus 2 is 28.5. So here there is a mistake. So I compensated here. 0.5 to 400 is 200 will get added up. So it is 11,400 meter. So plus 600, the total area is 600 plus this one, so 12,000 meter, which is 12 km. So option 4 is the correct answer. Four is the correct answer. This what explained here. Velocity is dx by dt. From this, I'll get x as integral v dt between the limits initial to the final position. The interpretation is area under the vt curve. So from 0 to 30.5 seconds, I can split it into two parts, 0 to 2 and then 2 to 30.5, because 0 to 2 the graph is different and from 2 to 30.5 the graph is different. So two areas, first area is half into base into height plus the bottom rectangle. So this is the triangle, the first, and then this is the rectangle, bottom rectangle. And then the second part, it's 28.5 into 400. It's just a rectangle. So simplifying, you'll get 12 kilometers. Option 4 is the correct one. To the next question. A body travels 102.5 meters in the nth second and 115.5 meters in the n plus 2th second. The acceleration is, you can pause under this question. So distance traveled in nth second is distance traveled in n seconds minus distance traveled in n minus 1 second. This result is derived. So ut, t will be 1 because time interval is 1, plus half a t square, where t is t2 minus t2 square minus t1 square. So this square minus this square. So I'll get 2n minus 1. This I already proved, it's very easy to prove. So the first one, distance traveled in nth second is this one, and distance traveled in n plus 2th second. U, this interval is 1, and then half a, instead of n, you have to put n plus 2, so it will become 2n 4 plus 3. This is the formula for distance traveled in nth second. So in this, if you put n equal to n plus 2, it will give you the expression for distance traveled in n plus 2th second. N plus 2, if you put 2n plus 4, 2n plus 4 and minus 1 will become plus 3. So this is given as 102.5 meter, and this is 115 meter SI units. So to find the acceleration, we can subtract these two, this minus this. So that will give half a, 2n and 2n will go 4 times, equal to 12.5. 115, 15 minus 2 is 13, 13 minus 0.5 is 12.5. So a equal to twice of this one, 25. Sorry, E is, here it is 2, so it will become this 12.5 by 2. So it's 6.25 SI units. 6.25, so option 2 is the correct answer. 2 is the correct answer. This is what I explained here. Distance traveled in n second is distance traveled in n seconds minus distance traveled in n minus 1 second, that is 102.5. It's given in the question. Distance traveled in n plus 2 second is distance traveled in n plus 2 seconds minus distance traveled in n plus 1 second. That is 115. So if you put this thing, you get the formula for distance traveled in n second is un plus half a n square minus u n minus 1 plus half a n minus 1 square, and deriving this relation using this. So simplifying, you'll get u plus half a 2n minus 1. So there is the distance traveled in n second. Derivative remember this ut, t is 1 because here the time interval is 1 plus half a t square, difference will become n square minus n minus 1 the full square. So I'll get this one. This is equal to 102.1. Distance traveled in n plus 2 second is, in this formula, put n equal to n plus 2. So subtracting, we will get acceleration as 6.25. This is the next question. The particle moves in a straight line so that the displacement x at any point, at any time, t is given as x square equal to 1 plus t square. Its acceleration at any time t is x raised to the power n minus n, where n is dash. You have to find the value of n. A straightforward question. X square equal to 1 plus t square. We have to find the acceleration. So differentiate both the sides with respect to time. 2x dx by dt equal to 2t. And then we have to find acceleration. So differentiate second time, uv rule. So if you differentiate x, you'll get dx by dt, that's velocity. This also velocity, so v square plus x into differentiate of this, that's acceleration, equal to 1. Differentiate of this one is dx by dt, which is velocity. That velocity into velocity is v square. And then next term, keep this one, and then differentiate this one with respect to time. It will become d square x by dt square, which is acceleration. Differential of this one is with respect to time is 1. And v square, from this I can write as t by x whole square. So using 1, v is t by x. So I can write v as t by x square plus x into a is 1. So v square is t square by x1. So acceleration is 1 minus t square by x square by x. And then t by x from here is v. Okay, this I can write as x square minus t square. X square minus t square by x cube. And from here, x square minus t square is 1. So it's 1 by x cube, which is x raised to the power minus 3. You have to compare with x raised to the minus 1. So n equal to 3. N equal to 3 is the correct answer. This is what I explained here. X square equal to 1 plus t square. Differentiate with respect to time on both the sides. You get 2x dx by dt equal to 2t. That is x into v is t. You have to get acceleration, so differentiate this thing again. So this, if you differentiate, you get velocity. So velocity is v square plus x into differential of this is a. That's equal to 1. So acceleration is 1 minus v square by x, and then v I can write from here as t by x. And then t square can be written as x square minus 1. Simple manipulation will get 1 by x cube. So n is 3. Do the next question. A ball is thrown vertically upwards with a velocity 90.6 meter per second from the top of a tower. The ball strikes the ground after 6 seconds. The height from the ground up to which the ball can rise will be k by 5 meters. The value of k is use g equal to 9.8 meter per second square. So say this is the tower. So the ball is thrown from here, it goes up and then it comes down. So this is the ground level. Okay, so the height of the maximum height point from the ground is k by 5, and we have to find k, and the initial velocity which is thrown upwards u is 19.6 meter per second. So this total time t is 6 seconds. Okay, so from this we have to find the value of this maximum height it reaches. So since 19.6 is given, we can find the time it takes to come at the same level. Let me call this A, maximum height point B, and then C, D. Okay, so S equal to ut plus half A t square. I apply between the points A and C. And I'll take the upward direction as positive. It's 1D motion. So this is the origin for that this thing, displacement. Upward direction is positive. So between A and C, the displacement is 0. Between A and C. And U is upward is positive 19.6 into the time it took to go from A to C. This half acceleration is downwards, so it should be minus. So minus g t ac square. So g is 9.8. So this is 2 times 9.8. So if we take 9.8 outside, it becomes 2 times t minus half 9.8 is come out t square. I can also take the t outside. So t is coming out to be 4 seconds. This is 0. T is 4 seconds. So the time to go from here to here is 4 seconds. That means the time to go from here to here, the first part is 2 seconds. The time to go from B to C is 2 seconds. And the time to go from C to D is 2 seconds, because the total time is 6 seconds. 4 seconds is split equally between this A, B and BC. By symmetry, AB equal to BC the time. So it's 2 and 2. And the total time is 6. So the remaining time is 2. So from here to here is 2. So now we have to find this maximum height. Further, I have to use this displacement between B and D. So I can write S equal to, same thing I can use. So S will become the height now. And then U is this U here, which is 0. So just half G is acceleration minus G. And then T square from here to here is 4 seconds. And this S is between B and D. And upward direction, so this displacement is negative. And the value of it is given as K. So displacement is minus K by 5. Because height is positive quantity, which is given as K by 5. With this as reference, this downward displacement is negative. And for this thing, I'm choosing this as origin. So 16 by 2, 8 G 9.8 minus sign. So from this, the value of k is 8 5s are 40, 40 times 9.8, 40 into 10 minus 0.2. So 400 minus 8. 9.8 is written as 10 minus 0.2. So 400 minus 8. So that is 392. SI units K. Okay, unit they have put there itself. So K is just a number, which is 392. That is the correct answer. So the ball is thrown from this top of the tower. It will go up. The velocity will decrease. It finally becomes 0 here and will turn back. So this initial velocity is given as 19.6 and the total time is given as 6. And this maximum height point is k by 5 from the ground, and you have to find the value of k. So is equal to ut plus half at square. I can apply between the points A and C to get this time from here to here. So between A and C, the displacement is 0. U is given. Upward direction is positive. So from this I get the time to go from A to C is 4 seconds. So by symmetry, the time to go from here is half of the total time, just 2 seconds. So total time is 6. So from here to here it's 2, from here to here it's 2. So remaining 2 will be from here to here. So if you take the points B and D, the displacement is U is 0 plus half A t square, time between the points B and D. Acceleration is minus G, and the displacement is from here to here, which is negative, and k by 5 is a positive quantity because just the height. From this, the value of k is 392. For this equation, I have taken the origin of the displacement as the point B. For this one, I take the origin of the displacement as point A. That can be done because I analyze this thing independently, and this thing is independent of the first part. Here's the next question. A particle is moving in a straight line, so the velocity is increasing at 5 meters per second per meter. Acceleration of the particle is dash meter per second square at a point where its velocity is 20 meter per second. So you have to find the acceleration when the velocity is 20. So what is given is velocity is increasing per meter. So dv by dx is given. That is 5 meter per second per second. This is meter per second. This what is given is dv by meter per meter. So from this I have to find the acceleration. Acceleration is dv by dt. This can be written as dv by dx into dx by dt. Dx and dx will cancel, give this one, because what is given is dv by dx, and this is nothing but v. So v into dv by dx. So here in this you have to put acceleration at velocity equal to 20 meter per second. So in this put v equal to 20 and dv by dx is given in the question as 5. It will be 100. That is the correct answer. dv by dx is 5 meter per second per meter. Acceleration is dv by dt. It can be written as dv by dx into dx by dt. And dv by dx is given in the question as 5. And then this is nothing but v. So to find the acceleration and the velocity equal to 20, put v equal to 20 here.